Well, we did some examples with numbers, but now what happens when we have variables instead? So for this first problem, we need to simplify y to the 1/7 power times y to the 4/7 power. But remember, the bases are the same, so we follow the rules for exponents. So when I'm multiplying and the bases are the same, I add the exponents. So 1/7 plus 4/7 is 5/7, and that's my answer. Now, if I was asked to put this into radical form, I could say this is the same as the 7th root of y to the 5th power. But unless you're specifically asked to do that, you wouldn't need to. On the next example, again, I need to remember that the negative sign means the reciprocal. So I'm going to start by saying this is 1 over x to the 2/3 power. But now remember that this means 1 over the cube root of x squared. And the problem is I can't leave a radical in the denominator because it's not in simplest form. Now I'm going to actually go back to the rational form to do this because I think it's going to be easier for you to see this. I need to multiply by something so that I just have an x, or if you want, think of it as an x to the 1st power. So think about, remember the rule, when you're multiplying and the bases are the same, you add the exponents. Well, what would I have to add to 2/3 to get 1 whole? Well, 2/3 plus 1/3 would equal 1 whole. So I'm going to multiply by x to the 1/3 power, because then 2/3 plus 1/3 is 3/3, or 1 whole. So whatever I do to the denominator, I do to the numerator, so I get x to the 1/3 over x. And you could just write it that way, x to the 1/3 over x. And that's actually your simplified answer. And again, I know you might look and say, well, this looks simpler what I started with. But to be in simplest form, you are not supposed to leave a square root in the denominator. And so, or sorry, it wasn't a square root, but a radical in the denominator. And so that's the process you would have to go through to simplify it. So if we try these, and you can pause this and try them if you want to on your own, and then come back to this and I'll work them out. So for the first one, we're going to have x to the 3/5 because we're going to just add the exponents. And for the next problem, we would start by switching it to 1 over y to the 3/4. And then I'm going to multiply by y to the 1/4. And for an answer, I end up with y to the 1/4 over y. And that would be my answer in simplest form. All right, some more examples here to look at. You'll find these much easier to simplify. Now, first of all, I can't just cross out the 2 and say 2 goes into 2 once and 2 goes into 16 8 times, because they're not the same roots. This is a 6th root, this is a cubed root. So what I'm going to do to start with is I'm going to write this as 16 to the 1/6 power divided by 2 to the 1/3 power. So I'm going to start by simplifying it that way. Now, unfortunately, I can't subtract the exponents because the bases aren't the same, and the rule says that the bases have to be the same. But I can change 16 and write it with a base of 2. 16 is the same as 2 to the 4th power. So I'm going to rewrite the 16 as 2 to the 4th power. And remember, that's still to the 1/6 power. Not changing this. Now I have a power to a power, so I multiply the exponents. 4 times the 6th is 4/6, and 4/6 reduces to 2/3. So I get 2 to the 2/3 divided by 2 to the 1/3. And now the bases are the same, so I subtract the exponents, and I get 2 to the 1/3 power, because 2/3 minus 1/3 is 1/3. Since my problem started out as a radical problem, I'm going to rewrite my answer in radical form. This is the cube root of 2, and that's actually the answer that I would give for this problem. So again, my process was to change these to rational exponents, get the bases the same so that I could use the rules for exponents. Okay, so let's see what we can do with this next one. Again, I'm going to write this in rational with a rational exponent. So when I do that, I have 4x to the 4th raised to the 1/6 power. Now, I'm going to write this because I know 4 is the same as 2 squared. So I'm going to write this as 2 squared x to the 4th to the 1/6. And now it's a power to a power, so I multiply the exponents. So I get 2, and my exponent, 2 times a 6th is 2/6, which reduces to 1/3. So I get 2 to the 1/3. And when I multiply powers, 4 times a 6 is 4/6, which reduces to 2/3. Now, because they're both thirds, that means it's a cube root, and they're both the same, so I can put them underneath the same radical with a 3 out front because they're cube roots. I'm going to have a 2 and an x squared. Just a 2 because it was to the first power, and it's x squared because it was the second power, but it's a cube root of 2x squared. And this would be the way I would write my answer for that. So again, my strategy was to rewrite them as a rational exponent, and then I guess I wasn't finding a common base like I did over here, but I was just kind of breaking it down so I can write it as a power, so I could use some rules to simplify the exponents. Now, on the previous two problems I did, my strategy was to write them as rational exponents, but on this one, actually my strategy is going to be to write it as a radical. So I'm going to change this to the square root. Remember, 1/2 power is square root. So the square root of y plus 1 over the square root of y minus 1. Now this becomes a problem like we did a couple days ago, yesterday or day before. And I need to simplify this, which means I don't want a radical in the denominator. So if you remember, our strategy was to multiply by the conjugate. So it would be the square root of y plus 1. So for my numerator, I can put that in a box. We have the square root of y plus 1 times the square root of y plus 1. Square root of y times the square root of y is y. Here I get the square root of y, square root of y. 1 times 1 is 1. So my numerator will be y plus, I have 2 root y plus 1. My denominator, I can put this in a box, or I can use my shortcut method, which was to square the first term. Square root of y squared is y, and square the second term, which is 1. Remember, that's the difference of 2 squares. So that would be my answer. Now remember, you can't cancel the y's because they're part of a sum or difference. So this would actually be in simplest form. Okay, so that's going to be it for the notes. And I do want to recognize that I know that a lot of the topics in today's lesson were kind of tough. Remember that when you come to class tomorrow, we will be practicing these problems in class. So if you kind of feel a little bit lost, that's okay. We're going to be working on these in class.